Hello, my name is Joshua Fernandez, and today I am solving Freecodecamp's intermediate algorithm scripting problem, sum all primes. And for this problem, we're given an input num, and we need to return the sum of all prime numbers preceding num. Okay, so num in this case would be 10. So we have to find the sum of all prime numbers preceding 10. So the prime numbers preceding 10 would be 2, 3, so that would be 5, 2, 3, 5, and 7. So 2 plus 3 is 5, plus 5 is 10, plus 7 is 17. So that would be, we would return 17, okay? So let's just console.log this so we can test the code. And we want to create a total, a variable called total, and set it equal to 0. This variable is going to contain the total of the prime numbers. And now we're going to create a while loop. We're going to create a while loop. And I is less than or equal to. So it's going to continue. It's going to start at 2. And it's going to check every number after 2 to see if it's a prime number. If it is a prime number, we're going to add it to our total here. So, and the reason we're starting at 2 is because 1 is not a prime number, so we can just skip that. But after 1, we're going to check to see if the number that we're iterating through is prime or not. So the way we're going to do this is with a for loop. Oh yeah, and also here at the end of our while loop, I++. So we're going to have a for loop to check. This is going to check if it's prime. And if it's not prime, then we want the for loop to stop and stop iterating, and we don't want to push, or we don't want to add that number, the I that we're iterating through. We don't want to add that to our total. So we just want the for loop to end, and we want I to increment by 1 to proceed to the next number, and we're going to check for that number. And so we're going to check if I modulus j is equal to 0, then we know it's prime. But then we also have to have one condition here, and I is not equal to j, because just because I modulus j, just because j can go evenly into I, doesn't mean it could still be prime if they are the same number. But so if they have to not be the same number, and then if j still goes into I, then we know it's not prime. Okay? Then we can set j equal to I. So if we set j equal to I and the for loop increments by 1, it's not going to pass this condition, and so it's not. So here, look, I'm going to show you over here. We're going to have an else if statement. Else if j is equal to I, then we can total plus equal to j. So we can, I. So we can add that number to our total. If this condition has not passed and j is equal to I, that means we know that it is a prime number. So we're going to add that number to our total. Okay? And so that should be, so now all we have to do is return our total. And oh, it looks like it's not working. Oh, I know why. So we actually want j to be equal to 2 because here we have to check if it's not a prime number, right? So if j can go into I evenly, then it's not a prime number, right? But remember, a prime number is a whole number that is greater than 1 with exactly 2 divisors, 1 in itself. So we don't want to include 1 in itself in this to check if it's not a prime number, because prime numbers can be divided by 1 in itself, and we want to check if it's not a prime number, so we want to exclude those conditions. So now it works. Its total is equal to 17. Let's run tests, and cool. So that was intermediate algorithm scripting sum all primes. The next problem that I'm going to solve is intermediate algorithm scripting smallest common multiple. So thank you for watching, and I'll see you in the next video. And